Hello, students. Good afternoon or morning, whatever time you're watching this. Today we're going to start our stoichiometry, our unit 3. First of all, we're going to start with balancing chemical equation. How do we balance equation? And this balancing equation is just to prove the law of conservation of mass. All right. So what we're going to do is to see that element on the right side of the equation is equal to one on the left side. So we have reactant, we have the product, the atoms on both sides must be equal. So let's see how we go about balancing the equation. In a chemical reaction, no atoms are created or destroyed. They simply recombine to form different compounds. That is the law of conservation of mass. All right, in chemical reaction, it is useful to indicate the phases of compounds. This is done by placing the appropriate labels in parentheses after the formulas of the compounds. So these are just introduction to what we're going to do. So use the following phase labels: G for gas, L for liquid, and S for AQ for aqueous. What is aqueous? Aqueous is when you dissolve any substance in water, becomes aqueous. So most of the time we consider water to be a universal solvent, which is liquid. All right. So chemical reactions are represented by chemical equations. Chemical equations consist of the reactants and the products. Consider this reaction. Al, S stands for solid, plus Fe2O3, that is iron 3 oxide, is also solid, to produce Al2O3 plus Fe. All right. So what you have on the left side is called the reactants. That means your Al plus Fe2O3 are reactants. That is the substance you added together. And what you get on the right side is your products. That arrow in the middle is like yield. All right, Al plus Fe2O3 yield or produce Al2O3 or formed Al2O3 plus Fe. Reactants are on the left-hand side, the equation, and products are on the right-hand side of the equation. So reactants on the left, products on the right. So let's look at another vocabulary which we call the coefficient. Now, the coefficient are the number in front of the equation. Remember, we have a small number at the, for instance, when you have Fe2O3, those small numbers are called subscripts, but the coefficients are the number in front, which signifies the mole, the number of moles of that substance or the elements. So those are the spaces in front of the formula. And those are the numbers we're going to use to balance our equation. And the coefficients are always a positive integers. So to balance a chemical reaction, only the coefficients can be changed. Remember, you cannot alter or change the subscripts. Those are part of the formula. It is not allowed. All right, these are what we call the subscript. This is the subscript. This is subscript 2 and 3. This other subscript 2, other subscript 3. So these are the subscript. The number in front of the Al, which we are going to find out, is going to be the coefficient that we're talking about, which is used to balance any. The balanced chemical equations contains the smallest possible coefficients. That means, remember in the middle school, when you have ratio 2 to 4, that becomes ratio 1 to 2. So always remember to use the smallest ratio. by the smallest proportion when you're balancing the equation. Right, on the left-hand side of the equation, there is one aluminum, all right? On the right side of the equation, there are two aluminum. You can see the subscript. So in order to make them equal, what do? You put 2 in front of aluminum on the left side to balance the aluminum on the right side. On the left-hand side of the equation, there are 2 iron. 2 iron. On the right side of the equation, there is only 1 ion, Fe. So what do? The coefficient of 2 is placed in front of Fe on the right-hand side. On the left-hand side of the equation, there are 3 oxygen. On the right-hand side of the equation, there are 1 oxygen. There are 3 oxygen, rather. Okay. So hence, oxygen is balanced. So you have 3 on both sides. Right, you have 3 oxygen on both sides of the equation. You have 3 oxygen, Fe2O3 and Al2O3. So if you check now, we can look at the equation now and see that when there is no coefficient in front of the equation, it is assumed or it is known to be 1. All right? So there is 1 in front of Fe2O3. There is 1 in front of Al2O3. All right, this method is called wrap method. Wrap means, I'm going to, let me see if we can use this. Wrap, R-A-P. All right, wrap means reactants, atom, and products. All right, reactant, atom, and products. That is the method we just used, which I'm going to use again in the next couple of examples. Okay. And the coefficient of reactants and products for the balance equation is 6. The sum of the coefficient of reactants of balance equation is 6. That is 2 plus 1 plus 1 plus 2. Ratio 2 to 1, 1 to 2. 2 to 1, 1 to 2. That is the mole ratio, and that is the coefficient of the balance equation. You can see that we have 2 in front of aluminum, 1 in front of iron oxide, iron 3 oxide, and then 1 in front of aluminum oxide, Al2O3, and 2 in front of iron, Fe. So the sum of all the coefficients are 6, 2 plus 1 plus 1 plus 2. Let's take another example.
A simple way to initiate balancing is to start with elements that are present in the least number of compounds.
On the left-hand side of the equation, there's one C.
On the right-hand side of the equation, there are 6 C.
Hence, a coefficient of 6 is placed for C on the left-hand side.
Next, it is best to balance hydrogen, since hydrogen is present in only 2 compounds.
On the left-hand side of the equation, there are 2 H.
On the right-hand side of the equation, there are 12 H.
Hence, a coefficient of 6 is placed for H on the left-hand side. On the left-hand side of the equation, there are 12 plus 6 equal 18O.
On the right-hand side of the equation, there are 6 plus 2 equals 8O. Hence, a coefficient of 6 is placed for O on the right-hand side.
Thus, the balanced chemical reaction is, note, when no coefficient appears, it is understood that the coefficient is 1.
Hence, the sum of coefficients of reactants and products for the balanced chemical reaction is 19.
So when you add up the coefficients together, 6 plus 6 plus 1 plus 6 gives you 19. In other words, this is just the mole ratio of the coefficient. 6 to 6, 1 to 6. Let's do some interactive activity.
Consider the reaction. These are the coefficients. A simple way to initiate balancing is to start with elements that are present in the least number of compounds.
On the left-hand side of the equation, there are 6 C's.
On the right-hand side of the equation, there is 1 C. Hence, a coefficient of 6 is placed for C on the right-hand side.
Next, it is best to balance hydrogen, since hydrogen is present in only 2 compounds.
On the left-hand side of the equation, there are 14 H's.
On the right-hand side of the equation, there are 2 H. Hence, a coefficient of 7 is placed for H on the right-hand side. On the right-hand side of the equation, plus 7 equal 19O.
On the left-hand side of the equation, there are 2 O's. Hence, in order to get an equal number of O's on both sides, we put a coefficient of 19 for O's on the left-hand side. Now, on the left-hand side, we have 38 O's.
Thus, in order to balance the equation, we double the coefficients of reactants and products except O on the left-hand side. Thus, the balanced chemical reaction is...
Hence, the sum of the coefficients of reactants and products for the balanced chemical reaction is 47.
All right, just make sure you pause the video as you're watching and then practice it before you move on with the video.
Consider the reaction. These are the coefficients. A simple way to initiate balancing is to start with elements that are present in the least number of compounds.
On the left-hand side of the equation, there are 2 Fe.
On the right-hand side of the equation, there is 1 Fe.
Hence, a coefficient of 2 is placed for Fe on the right-hand side.
On the left-hand side of the equation, there are 3 S.
On the right-hand side of the equation, there is 1 S.
Hence, a coefficient of 3 is placed for S on the right-hand side.
On the left-hand side of the equation, there is 1 N.
On the right-hand side, there are 6 N.
So what next? How do you balance the nitrogen on both sides? If one has the left-hand side has 1 and the right-hand side has 6.
Hence, a coefficient of 6 is placed for N on the left-hand side.
On the left-hand side, there are 12 plus 1 equals 13O.
On the right-hand side, there are 6 plus 12 equals 18O.
Hence, a coefficient of 6 on the left-hand side.
On the left-hand side, there are 18 plus 12 equals 30H.
So let's look at the number of hydrogen on the left-hand side. How do they get 30 hydrogen? If you look at this hydrogen here, let me just use this. This is hydrogen has 3 subscript. Multiplied by this 6, which is the coefficient, gives you 18. All right. And then here you have 2 hydrogen subscript multiplied by 6 will give you 12. And that is how they arrive at 30 hydrogen. And on the other side, you do the same thing. Here you have these 3, the subscript 3 outside the parentheses is distributed into the OH. So here you have 3 hydrogen times 2, which is the coefficient, will give you 6. All right, plus you have 4 hydrogen subscript here times these 2 outside the parentheses to give you 8. Now, 8 times 3, because this 3 is a coefficient which multiplies or distributed over everything behind it. So you have 4 times 2, 8 times 3, 24. 24. So 24 plus 6 will give us 30. All right? That is how the hydrogen atoms on both sides were calculated. All right, let me erase this. Can go on.
On the right-hand side, there are 6 plus 24 equal 30H.
Hence, we have equal number of H on both sides of the equation. Thus, the balanced chemical reaction is, note, when no coefficient appears, it is understood that the coefficient is 1.
Hence, the sum of coefficient products for the balanced chemical reaction is 18.
All right, make sure you pause the video, take notes, and look how it was done. You can play back as many times as you want. That is the essence of this video lesson.
Consider the reaction.
What are the coefficients?
All right, what are the coefficients of this? C3H8 plus O2 to give you CO2 plus H2O. The coefficients are the number in front, which of course they're all 1, 1, 1.
How many C are on the left-hand side?
How many C do you have?
How many C are on the right-hand side? Where should the coefficient of C be placed?
You place on which side? Is it on the reactant side or on the product side?
Enter the coefficient.
How many H's on the left-hand side?
All right. How many H do you have?
How many H are on the right-hand side?
How many H can you see on the right-hand side?
Where should the coefficient of H be placed?
All right. Where is the coefficient H goes?
What is the coefficient of H?
So how do you determine that? When you have H8 on the left-hand side and you have H2 on the right-hand side. So how do you make them equal? And what coefficient has to be there?
How many O are on the left-hand side?
How many oxygen do you have on the left-hand side? If you say 2, that's good.
How many O are on the right-hand side?
Now remember we have 2 different O's on the right-hand side. The one on CO2 and the one on H2O. All right. What is your final answer?
Where should the coefficient of O be placed? Enter the coefficient of O.
Hence, the sum of the coefficients of the balanced chemical equation is
All right. I hope you are able to learn something on this one. Let's see if we have one more. Okay, I think that should be okay for now. So we're going to stop here, then do more practice. Then we'll continue from here and get back to class.